So we are in for like for also a remarkable follow-up session. We are deeply grateful for the first set of speakers with their numbers, right? Images, visions, stories, and to you all for the ways you took in the materials and enlarged the various perspectives that have to be addressed and considered as we pursue safeguarding the Amazon for Brazil and the planet. So this session, we are calling it A World Without the Amazon, right? So we talked a lot about Amazonia today, this various, the situation, the various stakes, passions, and interests, right? So, and the title for this session actually came during the preparation, when Beto and Tasso, who have been here, I think 7 times in the last 3 months here, right? Back and forth, meeting with scientists, social scientists, and planning. So we had the fortune to meet with Stephen Pekala. And Stephen Pekala said, guys, you have to be draconian. You need to imagine the worst possible scenario to be able to advocate for a theory of victory. So let's imagine the world without the Amazon. And Stephen Pekala, who is a professor at Princeton of ecology and evolutionary biology, he's also a professor in the Princeton Environmental Institute, right? A key figure in all kinds of discussions related to climate change, to energy, to policy developments. And he said, wow, I know this wonderful scientist, Elena Shevlyakova, right? She's a senior climate modeler and co-chair of the Land Model Development Team of the Geophysics Fluid Dynamics Laboratory, which is a laboratory which actually created, right, climate modeling in the US, right? I think about 50 years ago to a certain extent, but it has state-of-the-art technology like unrivaled anywhere else. So Stephen and Elena did a modeling that they will share with us, and I will not say more about that. But we also wanted to hear from one of Brazil's most acclaimed climate scientists, Professor Paulo Artacho, who is a professor at the University of São Paulo, who has had a very distinguished career in Brazil and abroad, Harvard, NASA, did all the early studies of monitoring land use, deforestation in the Amazon. And all their bios, are listed on the website. I will not go into details. And we thought it would be a great treat to hear from our own Michael Oppenheimer, right, who is a professor of geosciences and international affairs, as well as the director of the Center for Policy Research on Energy and Environment at the Woodrow Wilson School here. He has played a key role in the Ipcc, in the Intergovernmental Panel on Climate Change, and our own Isabella Teixeira, right? He's co-chair of the International Resource Panel and former Minister of the Environment of Brazil. So we have a wonderful set of speakers. We have a very creative and frightening experiment, right? And then we will hear comments and questions from Professor Oppenheimer and Isabella Teixeira, and then we'll open up to you as well. So again, thank you all panelists, and we'll start with Professor Paulo Artacho, with his presentation. Okay.
Hello. Oops. Is it working? Yeah. Hello. Good afternoon to everybody. So before presenting the results from the modeling, let's take here a look in some of the issues associated with the difficulty in understanding the Amazonian ecosystem, not to say modeling the working of Amazonia. So first, it's important to know that Amazonia is a very unique ecosystem in the world, with global impacts, of course, in the hydrological cycle, carbon balance, and many socioeconomic issues, as you already heard from previous talk. And Amazonia is, of course, a key ecosystem in the Earth system. Amazonia is responsible for 15% of all net primary productivity, photosynthesis, let's say, in the world. It stores in between 100 and 120 billion of carbon. How much is this? this is roughly about 10 years of all fossil fuel burning. So we are talking a huge possible impact if this carbon goes into the atmosphere. Of course, we can never forget about biodiversity. Is at least responsible for 10% of the species, but it can be a much higher number because we don't know how many species are there. And then also in terms of the hydrology, it's the largest hydrological basin in the world with 18% of fresh water for the whole ocean. And then plays a major role in terms of climate stabilization, is the key heat source of water vapor and energy for the tropical atmosphere. So this is what we are talking about in scientific terms. But it's always important to have this in mind. Amazonia, it's important for the global climate, but also the global climate influences Amazonia very strongly. So let's not forget that, okay, we're talking about, okay, let's reduce deforestation here, but if we don't reduce fossil fuel emission here, bye-bye, does not matter. This workshop makes no sense because if you allow the temperature goes above 5 or 6 degrees, bye-bye Amazonia anyway. So that's important to have this in mind. So basically, deforestation versus reduction of fossil fuel emission is critical in our discussion. One important point, we talk about Amazonia as a single entity, as if Amazonia is very homogeneous and so on. Nothing is far from true. Actually, Amazonia is extremely diverse in terms of disease productivity, for instance, from 2.3 to 5 tons of carbon per hectare per year. So it's a huge changes from eastern to western Amazonia. Also, tree mortality is changing dramatically, but it's also lifetime of trees is very much different east to west part of Amazonia, and all possible indication I could put here 10 or 12 maps like this. So Amazonia is a very heterogeneous region, and solutions that can work in Pará could not work in Acre, could not work in Mato Grosso. So actually, we have to have this in mind also, because there will never be one single solution for Amazonia, and this is another important point. And in terms of a process that regulates greenhouse gas, changes in albedo, changes in water vapor emissions, and so on, that depends very much on the various land use that you have already in Amazonia. As you heard about, 19% was already deforested, and this has a lot of different emissions of aerosols, water vapor, VOCs, and many, many components that change the life of this very rich ecosystem into the atmosphere. This is the map of the observed increase in temperature for 1901. So you see that this increase is very much heterogeneous. So this is the latest Ipcc report of 1.5. So, but one important point, you see that the increase in terrestrial ecosystems is much larger than oceanic ecosystem because of the very large heat capacity of water. And you saw previous presentation mentioning how can you avoid reaching 1.5 degrees. Sorry to say, we had bad news that we actually already reached 1.5 degrees, where we live in terrestrial ecosystems. So this is a report from the special report on climate change on land that Elena and myself have put together. And actually, for terrestrial ecosystem where we live, we are already at 1.5 degrees. So do not say anymore that we are far away from 1.5, because this is global average, and global average has a lot of different meanings. So basically, we are there. And this increase in temperature have very important impacts in Amazonia. So this is a compilation of observed increase in temperature in South America. So you see that the San Francisco Basin, we already have 2.5 degrees. Eastern part of Amazonia, Pará state, we already are closer to 2.2 degrees in terms of heating. So Amazonia is already changing and changing a lot. So it's not a pristine region anymore. So climate change is putting a very important burden in the changes of key ecosystem properties. This is the change in the right, changes in precipitation. So you see that the anomaly of precipitation is, of course, very strong in the northeast part of Brazil and San Francisco Basin, and also in the eastern part of Amazonia. So actually, we are changing the hydrological cycle. We are changing several processes that are critical for the Amazonian ecosystem. In terms of future, this is one of the simulations for RCP 8.5 done by INPE, downscaling from CMIP 5. We see that the forecast of increase in temperature in the eastern part of Amazonia could be something in between 5 to 6 degrees. So it's a huge increase. So if you don't mitigate climate change, you forget about Amazonia. We are losing our time here because the forest will not be able to survive such extreme high temperature, and photosynthetic process will start to fail, and the forest will start to lose carbon to the atmosphere anyway, be it deforested or not. So that's an important point. And Amazon is changing a lot. The first change I will put some highlights here is this is the dry season length that is increasing in Amazonia very significantly. So a recent paper shows that the dry season length has increased by 6.5 days per decade over 30, 40, or 50 years. So this is a huge change in the length of the dry season. And here is the amount of precipitation during that increased dry season, that the precipitation is decreasing during the dry season, what feedbacks to fires. So basically, everything is extremely well connected in terms of processes that are happening in Amazonia. What about the hydrological cycle that is critical for the survival of a tropical rainforest? So recent papers have shown that the hydrological cycle is intensifying over Amazonia. So over the last 20 years, we see a very strong increase in the runoff of water in Óbidos, closer to the mouth of Amazonia, for both wet season, dry season, and the average in the year. This could be driven because of the tropical sea surface, tropical Atlantic sea surface temperature that is increasing also quickly, that can bring more water vapor to Amazonia, and Amazonia is just a huge processor of water vapor. So part of it is getting back to the Atlantic, to the river, and this is being intensified. So basically, we are changing the hydrological cycle for Amazonia. The issue of attribution is a very complex issue. We cannot say that this can be done by deforestation or this can be done by climate change, because, of course, science does not understand all the process that controls the hydrological cycle. Look at this just as observation of what's going on in Amazonia. Another important point in Amazonia, the increase in extreme climate. So this is from beginning of last century until 2016. This is the level of the river in Manaus during the flood period and during the dry period. So basically, the dry is getting drier in terms of extreme, and the floods are increasing. And the amplitude between dry and flood periods in Manaus is also increasing. And the forest is very sensitive to these extreme climates, as you're going to see very easily on the carbon balance. So this is another paper that shows the carbon cycle in Amazonia. So when I started to do these studies 30, 35 years ago, Amazonia was absorbing carbon from the atmosphere from the beginning of the LBA network in Amazonia at a rate of about 0.5 tons of carbon per hectare per year. So look what is happening to the net carbon flux. It's going down. And basically, why it's going down? Because tree mortality is increasing. So why tree mortality is increasing? One of the reasons is the drought in 2005, 2010, and the increase in climate extreme events. So basically, this is already happening in Amazonia that is affecting the role of Amazonia to absorb carbon from the atmosphere. To model all this is a very difficult task, you know. The first paper that we see in terms of modeling of the deforestation in Amazonia, how it affected the precipitation worldwide, was from Rony Avissar in 2004, in the very beginning of the LBA project. You see that at that time, you know, with very limiting computing facilities and very limited models, you can identify impacts far away from Amazonia through teleconnection to in the hydrological cycle. Elena will show much more sophisticated results than Rony Avissar was able to do that long time ago. And another important modeling effort was done by Carlos Nobre, Givon Sampaio, and others, shows how much from the original Amazonia bioma we could have left if you change 3 different scenarios for emissions, if you incorporate the role of fires into the ecosystem, and then basically in several different scenarios, we could lose a very significant fraction of the tropical rainforest because there will be less rain, there will be higher temperature, the effects of fires will be much stronger than we have today, and so the forest will not be able to survive this new, much harsh weather over Amazonia. So we could lose a significant fraction. We needed to do, of course, much more exercise like this with different models, different simulations, and so on and so on. And the special report on climate change and land also reports the issue of the feedbacks. Why this is important? Because never forgot that the Amazonian forest is a living organism. And sometimes models forget about that, you know? So how a living organism will react to all this change? That's a very difficult question. We don't have the answer for that yet. But for instance, the feedbacks for the Amazon here is basically through changes in precipitation, changes in evaporations. Some of them decrease the forest possibility, some of them increase it. But they are very different here from the boreal forest, where changes in albedo and other types of changes are much more important. So basically, the feedbacks is one of the critical issues and difficulties that the models have to deal with that. And one recent paper we published in Nature shows a different feedback, the feedback of human occupation in Amazonia. So basically, if you have the natural forest, you have a certain combination of emissions from volatile organic compounds that produce a certain type of aerosols that are cloud condensation nuclei. But if these emissions mixed up with the urban emissions from the city of Manaus or other anthropogenic activities, the population of the aerosols that are critical for the hydrological cycle changes dramatically, their hygroscopicity changes, and so we have the potential to change the hydrological cycle, not just changing water vapor fluxes, but also change the cloud condensation nuclei because of land use, land cover change. In terms of extreme weather, so this is a recent June 2019 to August 2019 map of extreme events worldwide. You see that you see quite significant extreme events in South America. So, but also you see in the other tropical forest here, and even you can have a record of extremes that are very important in terms of how Amazonia will react to climate change. And also, it's important to bring here that some simulations, these are average of 37 models from CMIP5, shows that a prediction of increasing temperature variability in Amazonia. Because one thing is low, you go up slowly in terms of temperature. But you see that for the summer and for the whole year, you see that the regions where tropical forests are in South America and also in Africa can have a very significant increase in temperature variability. So this can put the forest at risk very, very easily. And Ipcc took care of all these issues, you know, in the special report on climate change and land recently published. And basically the report is focused on 4 main topics. First, we needed to reduce deforestation. Second, we needed to quickly invest in reforestation and afforestation. Brazil, in the INDC for Brazil, have to reforest 12 million hectares until 2025. So it's just 6 years from now. The third topic is that for the land use, we needed to produce food for 10 billion people in 2050. That's not a very easy task. And in the end, you also eventually need some sustainable bioenergy that can play a role in the decarbonization of fossil fuel. So this compromise are different country by country, are different region by region. So you need to think how this can be applied for the Amazonian ecosystem. And always do not forget to reduce fossil fuel burning, because if you don't do that, bye-bye, none of these 4 things are relevant anymore. And finally, my last slide talks on the IPCC 1.5 degrees report, you know. So IPCC made projections. How can we reach 1.5 degrees? Very easy. Starting reducing next year, 2020, CO2 emission by about 3% per year until you have a net zero emission in 2050. And after that, you have to start removing CO2 from the atmosphere at a rate of about -10 to -15 gigatons of carbon per year. This is about 1/3 of all the fossil fuel burned today. Is this feasible? Probably not. But the only way known by science to remove CO2 from the atmosphere in a very efficient and effective way is photosynthesis. And this photosynthesis have to be done in tropical areas where radiation and water does not work in Alaska, will not work in Siberia. So what this means is that to reach this scenario, tropical regions are absolutely key for that. So that's some very important message, that tropical regions are not just forests that you live then there, but we need to find sustainable development ways to not just develop this forest, but for this forest to play a role in the ecosystem service that will be really needed by all of us in the second part of this century. So basically the message, I think, cannot be more obvious. Amazonia is key for global sustainability.
So I'm going to do the quick introduction, and then Elena's going to do the heavy lifting. It's true, as Joe and Tasso said, that they came to my office some time ago, and they said, "What should we do in this conference?" And I said, "Well, you know, I spent a lot of my time thinking about how to communicate environmental impacts, and I said, you know, it's a good idea to envision a world, come up with communication products that show a world scientifically, the impact of a world without the Amazonian rainforest in it altogether. We've got a saying in English, and I don't know if it'll translate well into the Portuguese, but it's that the spouting whale gets the harpoon, okay? And this is a metaphor from the 19th century. And so I was the whale in this case, and those guys had the harpoon, and they said, well, then why don't you do that? And so I immediately looked for someone who could do the heavy lifting, and that's what resulted in the presentation today. Now, I also want to say that this assignment was a target-rich assignment. The fact is that we have 4 big environmental problems in the world today, in my view, 4 really big ones. There's the climate problem, the food problem, how to meet doubled food demand at mid-century, the water problem, how to meet a 50% increase in water demand by mid-century, and the biodiversity problem, how to avert a mass extinction. And if anywhere in the world is the epicenter of the interaction of these 4 problems, it is obviously the Amazon, right? We just heard that in the previous talk. And what we decided to do is instead to focus only on one of these, but I want to emphasize that I could have given a talk on the value of the Amazon in any one of these areas, right? And we're only going to be focusing on the climate impacts. And we'll look at the global climate impacts, but we'll also look at the local climate impacts on the Amazonian region itself, which are extreme, all right? And I want to say at the beginning, though, that we're not in any way breaking new ground here. We've just seen a small sliver of the enormous amount of science that has gone on for 50 years on this subject, much of it done by eminent Brazilian scientists. So we are standing on the shoulders of giants and just giving you a little bit of new stuff. Now, it is new stuff, though, in the sense that we have here at Princeton, as you've heard, a climate modeling laboratory where climate models were originally invented. And this produces cutting-edge climate models. And Elaine and I have worked on for many years on the component of this model that handles the land surface and the exchange of matter, energy, and momentum between the land surface and the atmosphere. And we focus specifically on making sure this model works well for forests, which are the 900-pound gorilla in the carbon cycle, and specifically within that on tropical forests. We have a new paper looking at tropical data worldwide, and so this model is particularly suited to the task that you're about to see. The last thing I want to say is that although we're going to be showing you impacts of Amazonian land use, an extreme cartoon of Amazonian land use on Amazonian climate, we are ever present and have been ever present aware that the decisions about Amazonia are the right and responsibility and domain of the nations and peoples of the Amazon and absolutely no one else, including us. So with that, Elena, do the real talk. Thanks.
To be here, and thank you to João, who actually instigated the whole research project. And I have to tell you that this is really fresh out of the press. All these conversations happened in August when we're all on vacation, so we literally started to do the simulation in September. So results are new, and the caveat, we're still investigating it. If anybody is curious, we're happy to share results and do more analysis. But just this is new stuff, and we're learning as quickly as we can. But there's a lot of things to investigate. And I particularly would like to acknowledge my colleague and collaborator, Sergei Malyshev, who actually run those simulations, because it takes the whole village to make a model, and there's dozens of scientists, oceanic, atmospheric, land modelers, chemists, who actually put their effort in building the GFDL models, which we're gonna use here. And as Paolo mentioned, in this climate change and land report, which just came out in August from Ipcc, which was a collaboration between 3 working groups. It's not just physical scientists, but people who work on impacts, people who work on policy and mitigation. This is, again, very unusual in the Ipcc process. two key findings, which were highlighted in a summary for policymakers, is that changes in land conditions from human use or climate change have capacity in turn to affect regional and global climate. And it's something that not been brought up before in the previous assessments and the reports. And regional climate change can be dampened or enhanced by changes in local land cover and land use. So what it means, it's not just atmospheric CO2, which often come into the discussions in the political meetings, but also what do people do on the land. So every carbon matter and every tree which can be cut or grown will matter for the globe and for the region. And again, like as Steve said, this is not new idea. And we adapt to the study which was pioneered in 1990 by Shukla, Nobre, and Sellers, and Carlos here is in the audience. And I also would like you to pay attention to the numbers, because a lot of the prediction which Carlos made about magnitude of effects still stay true, which I think is amazing that those results still valid. And Carlos, can speak better about the details of it, but just to introduce the idea of the experimental design for this study is very similar to what had been done back in 1990. So at that time, like the scientists ran atmospheric global circulation, general circulation model. And what they did, they prescribed sea surface temperatures from observations. And then they had a 1-year simulation, and they look at changes in the temperature, which is shown on the left panel, and 2.4 is in centigrade. It's not Fahrenheit, because most of the world use the different unit systems. And these are the changes, and the dashes mean decreases, and the solid means increases in precipitation. And you could see the heart of Amazon is up to 800 millimeters a year. And there were. So what we're doing here, we're updating in some sense that type of design. And I'm going to briefly explain you some elements of what we're doing in terms of both the models, but in terms of scenarios themselves. So we're using so-called Earth system models, or ASM4. This is a new model which our lab developed to participate in a couple model and comparison projects, phase 6, which serves as a basis for a lot of projections then I use then in Ipcc assessments. And it takes multiple climate centers around the world. So we're one of the many participating, and we have 2 models. This is one of them. And the scenarios, the simulations I'm going to show you quite different from most of those experiments, because Earth system models can be run by emissions of CO2 or other greenhouse gases. Because usually what happens, people prescribe concentration and they see what happened. The advantage of doing emissions from CO2, you could actually capture some of biogeochemical feedbacks, which Paula mentioned, that it means those models would show you how much carbon goes into ocean or how much of it goes into land or how much is released due to land use. So we are actually simulating and predicting not just the temperature or precipitation, but also how much CO2 would be in atmosphere, which is not typically done in concentration-driven simulations. And we're going to look at the differences in temperatures forward at 2050, which is about 30 years from now, so some of us could survive. Our children definitely will see that climate. And the scenarios now for the future, they call shared socioeconomic pathways, and we're going to look at the world which people envision being still friendly to the Earth ecosystem and to people, which would stabilize at 1.5 degree, and this is referred to as SSP1. And I'll go into detail and show you a little bit of what it means for the land use. But also, if we do nothing, if we continue as we did before, it's called baseline or business as usual scenario, and it's called SSP5. And those scenarios are developed by, again, CMIP group, and they're done by different type of models called integrated assessment models. They're not climate models, but they make some assumptions about climate. They make some assumption about technologies. They made some assumption about population growth and innovations in agriculture and technology. And those IMs, those scenarios become drivers of the climate models. So they have some sort of story about the future. They have a story about the humans. And they also include scenarios of land use change. So they actually assume not just radiative forcing, but they tell us what would be the transitions to pasture and croplands. And what we're doing in this experiment is very similar to what Carlos did. We remove 100% of the Amazon or we remove also 50% of Amazon to see if it makes a difference. And we're going to look at the 20-year average, because climate is actually a multi-year state. So we're going to look at the average around 2050. So we run the simulations to 2060. And we're going to compare the world according to these scenarios, which Simi thinks might happen, or brackets our future, with the future in which there is no Amazon. And we tried to do it simpler a little bit than Carlos did. So we just cut out all the forest in the domain between 18 south and 10 north, 82 west, and 34 west. We just took a chunk of the world and made it pasture. Okay? So just to give you a brief idea what's in the climate models, you have actually very sophisticated process-based models of the ocean circulation, ocean physics, land physics and hydrology. There is atmospheric circulation and physics, including radiation. In this particular model, we're also using full atmospheric chemistry, and there is interaction with aerosols. And aerosols and chemistry create a very specific regional effects, both on hydrological cycle and on temperatures. So, and we could use this model to predict both to evaluate what happened historically from pre-industrial, because that will make sure the model actually does anything reasonably reminding the Earth, but also what might happen in the future, which is what's called projections. And this model allows to explore both biogeochemical feedbacks from carbon cycle, actually if plants grow or don't grow, how they release the water, and also biophysical feedbacks. And by biophysical, we mean changes in albedo, surface roughness, like how big those things which might break the wind flows. And also we could look at the impacts of the climate change on the surface together with land use changes, okay? And just some, I don't think it's my latest presentation, but it's okay. Sorry, because I have another update, but they didn't put it on. It's okay, but what happens, right? So I'm going to point out what we mean by resolution. And the resolution means that, we divide the globe into little boxes. And the size of that box, scientists refer to resolution, because you don't have computer power to represent every pixel in the world. So in atmosphere, the size of that box, and on land, it's about 100 kilometers. In an ocean, it's about 50 kilometers. So, and inside the land, we break it into further parts, and we represent different land use type. So in some sense, our land resolution is higher than our atmospheric resolution. It varies around the world depending on how many different type of land uses we have. And you've seen that picture. So in our land model, we could grow trees, we could grow grasses. If we cut the forest, all that CO2 comes back. If you have a desert, there is a dust going on atmosphere. So it's a variety of interactions there. But we could do that subgrid heterogeneity in every scale. Just to give you an idea, it takes about 6,000 computer processors to run that model. So it's a major endeavor. It's not something I could do on my laptop. And it takes about 8 years a day. We could do 8 years of computer model in one day. So to do multi-decadal simulation, sometimes we have to take a few weeks if computer works. So, and we also do historical and future projections. So let me explain a little bit about shared socioeconomic pathways, because there's some assumptions made in there which are not consistent with what's happening in Amazon. And this is SP1, which would get us to 1.5. Sometimes we think about the green road. It has lowest lowest warming greenhouse gas emissions. And it also assumes that in order to get to that world, we will cut drastically consumption of meat. That's why the pastures shown in the black line are going to go down. Crops in these simulations in these scenarios are going up. And it's because it includes bioenergy and biocrops. And forests are assumed to be increasing because we're doing afforestation and deforestation. This is not coming from our model. It's coming from those scenarios produced in model from IAMS. And there is another fossil fuel development scenario, SP5, as I mentioned. And there is a 8.5 watts warming. And depending on the model, you could go anywhere from 5 to 7 degree warming by the end of 21st century. So, and even that scenario assumes that the tropical deforestation rates will decrease. So this is our worst case scenario, which does not expect that we'll cut more tropical forests. So, And in that scenario, that we also see the crops are increasing, pastures are decreasing, but rates of the loss of tropical forests presumably stop somewhere in the mid-21st century. That's what people believe it could be the worst case happening. So what I'm going to show now are the changes in surface temperature between world, according to SSPs, and the change and the temperature which you will get if you cut the Amazon. It's basically things on top of those red maps which Paolo showed you before. So it's additional warming from land use, from deforestation alone. So on the left, that's the case if you take SSP and you cut 100% of forest, and then middle case, it's only 50% of forest, and that's when you go to SSP 5. That's sort of like business as usual scenario, and you're at 50% only. The red here, deep red, it's up to 2 degrees of sea warming. So unfortunately, the original slides, as I didn't make it through. But under SSP1, the pre-industrial warming in Amazon is about 2.5 in the best case scenario. So what it means, if you basically cut the forest, you're already going to be 4.5 degrees above what you were in 1850. So this is about half. For the half of deforestation, the model projects about half of the warming. So it's about like 1 degree around here. But what was surprising to us, if you go to the warmer world, business as usual warm, on top of that warming, which could be 5-7 degrees, you also get another 2 degrees of warming. So this is something like 9 degrees above the pre-industrial, which is like Paula said, it's end of the Amazon. You might be Cerrado there or some other savannas, but it's very hard to imagine that unless science completely wrong, which I hope it is, we would not be able to have tropical forest there. So, and why is it happening? And partly because there is a response of hydrological cycle to that warming. Again, these are differences in precipitation in addition to the ones which you would get from scenario alone. And what is it? So here you see that there's a major reductions. Red again here, it's about 2 millimeters a day. If you multiply it by 365, you get the numbers which Dr. Nober showed. It's about 730, 800 millimeters a year. So you're going to lose the water over major regions of, South America. If you go to the 50% deforestation, you still have, extensive losses of precipitation, but it's not as widespread. And if you go to 50% of the business as usual scenario, you also get major losses, and it's very extensive as well. So what we're finding is that it also has implications for stream flow. And I apologize, this is a funny units here. It's millimeters of water per day per the area of the grid cell where it was computed. What it basically shows that the changes in evaporation, changes in precipitation, going to produce major reduction in the river flows, especially in Amazonian basin. And those, the 100% produces the biggest case, but even in the 50%, you could see that major implications for hydro flows in the rivers. So, and we could go deep down, and look at many other variables. There's dozens of variables in this model, which just didn't have time. But it's going to be widespread and massive changes in the way ecosystems work, in the way hydrological cycle works in the region, and the climate's never going to be the same. A lot of people point out it would be a novel climate. It would be climate like we never experienced before. So what we're finding is that 100% deforestation produces large, up to 2.5 degree warming, and extensive reductions in precipitation under ambitious scenarios. Even in the best case scenario, which people can envision, Amazon is going to be done as we know it. But even with 50% deforestation, we're going to have half of effect. But if we remain on this fossil fuel diet, as we do now, again, that would be a major losses of the ecosystem services and major losses of the climate as we know it. So, but what does it mean for the global, right? So, because this is a global model, I just zoomed in on what we did. And again, we found very surprising that you could see that effect of the deforestation over 100% deforestation results in a global increase of the temperature. It's about 1/4 degree. And the atmospheric CO2 concentration would be 30 ppm higher. So in this model, instead of being 450 ppm, it's going to be 480 ppm. And this is mid-21st century. We're not talking about the end of the century. So what it means that we're going to be far less likely to keep global warming under 1.5 since the pre-industrial period. So the whole Paris Agreement is not going to get us there if we're going to lose the Amazon. And you also see that most of the impact of Amazon deforestation is going to be local. You know, some of that could be noise, some of it it's poleward amplification, but the biggest threats in temperature and the biggest threats in precipitation are over South America. So it's very essential that people understand that these changes are local, and they're also going to mean a lot for the world. So the world must care about what's happening there. And there are interesting patterns in terms of precipitation and changes in the circulation. We haven't had a chance to look at it in detail, but it's going to affect not just South America locally, but a lot of tropical regions, like where the extremes of precipitation are going to be happening right now. So it's a major thing. It's not a small story which affects just Brazil. And again, if you look at the 8.5 scenario, you know, the global temperatures are higher. It's, you know, the business as usual scenario. CO2 is only 15 ppmv, but substantial regional warming over tropical South America. So it's still a bad story in any way you look at it. So what we're finding is that in summary, the world without Amazon results in substantially warmer and drier Amazonia under both ambitious and baseline scenarios due to regional biophysical feedbacks. And we will be less likely to reach Paris Agreement goals, including climate change stabilization under 1.5. So that's what we found. So.
Okay. Great. So, Michael.
So that's a depressing little picture. Let me do this by asking a few questions. This one is for either Steve or Elena. Have you thought about the responses that are likely to happen if climate change proceeds and if the forest goes into progressively worse shape, and if cutting and burning proceeds? At some point, the combination of the greenhouse gas force changes and the human force, the degradation of the forest due to direct assault from humans, gets to the point where areas of the forest essentially become unusable for what they've been used for. And there's a point at which presumably people change their behavior in response to those losses. Some of this may be embedded in the SSPs, I'm not sure. And you could imagine situations where the degradation accelerates because there's kind of a rush to cut the last tree and plant the last crop and pasture the last animal. But you could also imagine the opposite happening, that at some point things kind of stabilize because there's a rebound effect, and the benefit of what you're doing, all this exploitation runs out. Have you thought about that at all? I know it's not in the model. It would be nice if we could put it in. Well, it's not in the sense as Steve.
It's not an experiment.
Yeah, it's not an experiment.
So there's a lot in that question. I'll answer two parts of it. The first is technical, and the question is, does a modern climate model include economic feedbacks of land use on climate that then further impacts climate? And the answer is they don't really do so interactively. There's no global marketplace of commodities and that sort of things that moves the agriculture around and that changes agriculture. It does include an enormous amount of feedback between the land surface and the atmosphere. The natural vegetation and the biomes of the world move all around according to their own internal feedbacks that come from scientific studies. And so that system is, in a sense, fully coupled in the way that you would want it to be. But there is a real need, I think, to couple the human system of land use dynamically into the climate model so it can be responsive in precisely that same way, so that when the climate changes in a particular way in some scenario, people behave, their land use behaves according to some set of rules that can be studied and codified. All right. With that said, it's also useful to just point out that there's a lot of work done on Amazonian tipping points. So does land use change the climate in some way that would prevent the rainforest from returning if humanity decided to cause it to return, to reforest the Amazon? And it's possible, in fact, that the climate can change enough that that becomes impossible. There is still, Carlos Nobres has done more on that than anyone, I think. But it's, while there is still some scientific debate on where that point might be, it's important to understand that from an economic perspective or from a political perspective, the issue is settled. Even if you could reestablish the hydrologic cycle of the Amazon, if you decided to do so, it would take so long, right, that it's for all intents and purposes economically irreversible.
I just want to add that as a scientist, you always make those models and you hope that they could be as good as possible, but you also know they're imperfect. And I think putting faith that even the model predicts some sort of return, maybe many decades later, it might be helpful, but I think society needs to be much more cautious and much more risk averse in making decisions which might not necessarily be absolutely bulletproof from scientific point of view. Because a lot of things which, Paolo talked about, like aerosol feedbacks, nutrient feedbacks, people still arguing are they phosphorus or nutrient limiting, are still poorly understood. And we don't have the models which as good as, let's say, predicting of the weather, let's say, because it just system is fundamentally chaotic. So in that sense, these are called projections, they're not predictions. And I think they inform us about something we could lose. But hoping that something we could gain, I think need to be taken with a grain of salt.
But in theory, at some time in the future, some of these processes can be included in a way that's quasi-realistic.
They are included already. I think that's what you see in the scenarios like SSP1, because the reason you get negative emissions because they assume going to be massive afforestation, massive reforestation, but there is no field experiments, there is no actual observations to support that. So in some sense, I would think IMs are optimists and DCMers are pessimists, and we just want to be cautious. But the models can do it. But I won't try.
So, Isabella, do you want to go? I have another question, but
Okay, I don't know if I have a question. I think that it's okay here?
Just pass it around.
No? Okay, hello. I'm here. Okay. First of all, I'd like to thank you very much for the presentation and also for the first comments. And in my opinion, as a woman from the political world, this means that Brazil has a carbon bomb, not a bomb of neutrons, but a bomb of carbons. And this is easy for our president to understand better his work or his missions. His language, this is perfect, okay? And it's not only what this study presents, but also what Paulo mentioned before, the strategic links that we have between climate change and Amazonian preservation, and to avoid deforestation, to block deforestation in Brazil, not only Brazil, but in Amazon basin. This is the first aspect that I'd like to highlight here. Brazil is a key player, but we need the partnership with other countries, okay? And this is crucial at the political level. We are talking about Amazon basin, not one Amazon basin in Brazil, or Amazon forest in Brazil. So this is a huge opportunity, not only to bring the scientists together with the political world, but also to bring other countries together with us, okay, and because they are crucial for decision process at the global level. But as everybody knows that I like to speak a lot, and you don't have time, okay? And I want to also to preserve you of my Brazilian English, okay? I like to read some points, consider the political world and the political dimensions. Why will be a fact not only with these outcomes or the results that you present and also you, but what the key challenges, what are the dimensions that Amazonian protection did means today for the politics and also what we need in Brazil. So if you allow me, I'd like to highlight some points here, not only to a better dialogue between policymakers and scientists, but also for tomorrow, okay? Because we have a session to discuss emerging issues, good ideas, and how we can bring people together. And this is crucial for Brazil also, okay? So first of all, thank you very much for inviting me to come, Tasso, and also Beto. And I was in Japan, and for me, I was able to avoid the typhoon, okay? And now I'm here to avoid deforestation. Let's see what's happening in the world. And I do believe that a science policy, we have a science and policy-oriented challenge. And this is very important to understand because sometimes for the politics world, this is not clear enough. How we can bring scientists into the room. And we have a governor of state of Pará here, former minister, together we're together in the same show, I don't know. But, my feeling is that it's very important to understand how to bring scientists, how to bring science into the political world. Okay, it's not only based on studies that are very important, but also based on the new political language. Okay, and for the political world, Brazil has unique importance because of the Amazon and its democracy. This is the first point that I'd like to highlight here. Okay, and this means a lot. Today, at the global level, as an international forum, it's absolutely strategic that Brazil can preserve Amazonia, and also climate change is part of this, but also preserve our democracy. Okay, and I'll try to explain this better in the next point. This session also allows us to debate a world without Amazon based on the scientific assumptions. And Tas was yesterday trying to explain me the study that's supposed to come in today without reading this, but it's very nice, okay? And it's clear that Amazon has a past, but Amazon must have a future. And this is a better one, I hope so. This is key when you are looking for to bring scientists together with us. The ecosystem transformation, the global climate impact, suggests that we need to organize the problems also according to the effects of a world without the Amazon. And this is something that I'm convinced that nobody is discussing at the moment, even on climate change constituents. And you know the impact of Ipcc report, the new one, and what was the policymakers' reaction against assume this as a key guidelines to make Paris Agreement implementation faster and more than faster, robust than to have today. Probably we need other Gretas, okay, as soon as possible, even from Brazil. I'm looking for the Brazilian Gretas, okay, and we have really good ones now from Engajamundo, the other one, but we need new ones, okay. And in both scenarios presented here, we can foresee implications for the Brazilian economy and social agenda. The potential economy and social damages are alarming because of the rise of the temperature and disruption in rainfall, if I understand. Okay, what is this? What it means that Brazil and its global implications, land use, agriculture, forestry, energy, etc., probably we will lose our role of the international role of food security, water security, energy security, and climate security. For the political world, this is a big disaster, okay? And it means investments, it means geopolitical roles, etc., etc., okay? And this study, it's very crucial, exactly, these both presentations, is exactly to show what is the new pathway you'd like to assume, consider your political role at the global level and the regional level, as I mentioned before. Change is coming, I'm so sorry, and it's as simple as that, okay? And the climate change is one of the critical global issues of the Center for Human Integrity. This is a new concept, okay? Human integrity means, in addition to migration, environmental displacement, and health and climate change. And this is a concept from the State Department of United States, okay? And you exactly manage this, consider defense and security at the global level. And Amazon protection is essential for tackling climate change. Global climate impact, one of the multiple political dimensions of the Amazon. There is somebody, or anyone here in this home that knows the numbers of Venezuela migrations until the end of this year and the projections for 2020? Do you know how many people have today in the migration process? Huh? Venezuela. 3 million? No. The scenarios is 5 million, and the projection is to achieve 10 million people. It's the second movement after Syria of migration global movement in the world. This will happen in Amazonia. Okay? So that's why human integrity has a different dimension in climate change always. Yes. Okay? If you think this is a state, is this? This is the OEA, it is American, like to say in English, American States Organizations data that have the projected, the last seminar that present this. And Untitled, and also ACNUR presented something like this last month, okay? And it's around 5 million people today, and the projections, they're really worst, but for me, 5 million is enough, okay? I don't need the projections, okay? I believe. If we think about examples of Brazilian leapfrog in the last 50 years, and you mentioned this before, it's vital to observe the motivation, the political and economic ones, okay? The trade-offs, the impacts, the science and the political will, and the decision process. We cannot forget that before biofuels or ethanol and pre-salt oil and gas exploitation technologies, okay, it's changing also our energy mix today in Brazil, okay? You have, first of all, democracy, and our federal constitution in Brazil is a leapfrogging. Don't forget this, please, okay? Because if you want to discuss indigenous people rights, this is based and recognized in our federal constitution. And the guys are looking forward to change this today, okay? And so take care, because I'm a part of a generation, you are also, Beto, that we fight a lot to have democracy in this country, in our country, okay? And also, we cannot forget that food production based on the soil technological revolution, Cerrado, it was strategic as a leapfrog in Brazil, okay? Brazil, 45 years or 50 years ago, 50 years ago, imported food. And today, one of the most important players in food production in the world. These are a good example of what are the driving political forces that put pressure on us, not only to delay or to avoid or to change our approach, or even to create concepts like transition, okay? This is a new concept, political concept, that you like to use to understand better how we'll move this faster or not, or if you want to avoid additional discussion, you bring this into the political rooms. Take care. Today in G20 block, we're discussing transitions, okay? Transitions, not transition. And it's very interesting to observe this, consider the global dynamics. Vaccines and health, and also I'd like to highlight one important leapfrog in Brazil, Bossa Nova, okay? This is culture. It's very interesting. We cannot forget our culture. That's why in Brazil, leapfrog means leap cat, because we have 7 lives, okay? This is politics. Don't forget this, okay? And of course, as you mentioned, the satellite monitoring systems and other ones that you can describe here or try to explore better and probably tomorrow. But don't forget the political will, the reason, the needs, the arrangements, and also the trade-offs that were necessary to tackle, to take decision, and why you took decision, okay? And Amazonia needs this. We need, for leapfrogging, we need to get out of the comfort zone. And this is the big problem that we have today in Brazil, considering Amazon protection. That's why nobody asks why people agree to go against, to be against deforestation in Amazonia, but it's not able to promote a new political constituency in Amazonia, and also to have a congressman that legitimates in democracy Amazon protection. Okay, we need to understand this better if you want a new agenda, and you need a new agenda. But I'll go to the critical points now because I don't have much time, and Tasso probably wants to kill me. But it's very important that one of the things we must remember is that this past reference of leapfrogging relied fundamentally on public investments. Okay? You like to talk about public flows and private financial flows, but our history illustrates that public investors were key for the leapfrogging in the past, even for the science development. Okay? This is a new way to discuss. We need a new way to discuss how we can finance this. Okay? It's not only bioeconomy, but how we can finance other agendas here. You know, we have a new understanding about public finance, consider the challenge that we have in Brazil and also in the world. This is something that climate change is fighting, and there is no solution. Okay? But it was because of why this happened. It was because of the state and not of the entrepreneurs, okay, that the conditions which allowed these sectors to flourish were created, making Brazil become a reference in these issues in today's globalized world. Okay, so sometimes when you like to talk about supply chains, et cetera, we need, in my opinion, to create new political conditions to understand better our challenges, okay? But we currently lack the politics and the political constituents for leapfrogging in the Amazon, in Brazil, and unfortunately in the world. Okay? We must build this, and there is no better moment than now. Why? Because the past is not solved and threatens us based on destructions, illegalities, corruptions, risks, and vulnerabilities, and the world is changing. I'm sorry. And I'm not saying we need to react according to the former institutional, economic, and political frameworks. Forget it. Okay? We need to act based on the transitions that the world is undergoing with the ambition to play an innovative and constructive role at the emerging planet. The decision is to be in or out of the new global connected society. Okay? Amazonia, so I'm sorry, the world is not flat. Okay? And Amazonia must be connected, and this is key. If you go out of Belém or Manaus, it's impossible to use mobile. Okay, and we need to understand what are the challenges of connection. What's the new global society, connect global society, and Amazonia is part of this. Okay, because Amazonia is an instrument to manage better climate change and also sustainability. And it is strategic and essential for our democracy and the new generation. If you're not able to be connected, if you're not able to be part of the new global society, connect society, unfortunately, our democracy will put in checkmate. Protecting the Amazon is a global and national cause. Okay? It's important should be seen by Brazilian society as the project for the future, not as the problem of the past. On the pragmatic basis, if you want to envision a prosperous future for the Amazon, we will need to bring in other players into the room based on their level of ambition, shared values, political will, and a shared sense of responsibility. This is a precondition to invite the guys. Okay? It's absolutely, we are doing this around the world to discuss the new challenge on climate change. Okay? It's not greenwashing. Remember that we have 50 shades of green. The Q1 is dollar green, okay? Don't forget this in the politics world. So we have learned how to build the problem framework with numbers, robust science, and lessons learned from our recent history of large-scale innovation. We know a lot about problems. We are like a good psychiatrist. We know a lot about problems. I'd like to suggest that we need to observe new strategic dimensions, including, I will list 3 or 4 issues, but we need numbers, science for this. We need political knowledge for this. The first one is the geopolitics, international and regional cooperation, and the driving force of climate change innovation. Look, it's absolutely important that we can discuss a new, how can I say this, a new belt, I use in quotes this expression, between Amazonia Basin, Amazonia region, and Eurasia, that is now proposing, we've been developing at the global level, as a new block. If you're not part of this, forget to talk about commodities, et cetera, et cetera. Okay, because there you have the tradable the tradable commodities that must be based on compliance and science, low carbon, everything that you can use here. So we need to be ambitious to think strategically the role of Amazonia, the geopolitical role of Amazonia, and Brazil is a key player because Brazil has the leadership of the process. Okay, and trade. We are talking about geopolitics. We are talking about regional cooperation, international cooperation. We are talking about innovation. Don't forget the multilateralism checkmate today. Okay, and we are looking forward to address new solutions for the multilateral system, and trade. Then it's absolutely important for this. You have the new regional blocks, the new multilateralism, the Amazon protection. Also, what will be tradable based on the consumer's values and a more stakeholder-secure model of capitalism and business interests. Okay, the first paper about this was published in 1979. And the big capitalists that wrote about this, the big players, was completely condemned. And now it's a reference, okay? More than almost 40 years, okay, to make a reference. So it's very interesting to understand this dimension. The second one is defense and security. Don't forget this, and Ilona probably can talk tomorrow more about this. We cannot forget security, of course. You have organized crime, at some mentioned here before in Amazonia, deforestation, you have animal traffic, you have drugs, you have different problems in the regions, okay? And this is part of deforestation because they finance deforestation, the illegal deforestation in Brazil, okay? And not only Brazil, I'm so sorry. But we need to exert or to exercise sovereignty in the context of the global issues and the tipping points. It's not based on the old concepts as today, unfortunately. We have some players in Brazil that like to use this against Brazil, in my opinion, okay? And this means that Amazonia is connected and protected under Brazilian society responsibility. This is how to exert sovereignty. This is democracy, okay? And we are discussing this into climate change, consider security and consider defense at the global level, okay? Economy. This everybody loves this too much. I don't like too much, but I need to mention this. We had the new ones, as tomorrow we'll discuss a lot, like bioeconomy. We are discussing now new perspectives concerning Amazon free trade in Manaus, et cetera, but we have Professor Nobre that will discuss more and more with us tomorrow. But we have bioeconomy, we have green economy, we have low carbon economy, we have the circular economy. Come on, bring everybody together. Okay, it's impossible, okay? And I'm ending, I promise. Take care. I'm exhausted. I came from Japan, okay? And also, we have to renew the old economy. If you believe that you have Amazonia without the old economy, forget it, mining, forestry, we need to renew this. We need to understand this better. And gaps of infrastructure and logistics must be better understood, consider the challenge that you have. It's impossible to promote development without understanding better the new role of infrastructure and logistics. Informality is a key issue that must be addressed. Science and technology, innovation, as we have met, connectivity, digital economy, and the digital revolution. Everything this is happening today, okay? I was in Boao Forum in China on March. It's a new world that's coming, considering artificial intelligence and also the digital economy. It's changing everything, okay? We need to be prepared, even for food production. If the agribusiness in Brazil believes that we will produce food based on the old ways, I'm so sorry. We have something new that's coming that will change everything. The two last points. We need a human development agenda, okay? It's not a social agenda, a human development agenda. Indigenous people must be part of this. And we need to create jobs, health care, lifestyle, everything that we can illustrate this. An urban agenda, cities, is absolutely important in Amazonia. We need a new idea for the Amazon cities. And connectivity, because Brazil will be around 90% of the population will be living in cities. Okay? And if we need to change the concept and understand of urban or cities in Amazonia, but it's absolutely important that we can understand this. First, the last point, public governance. We need to review everything, even for the national environmental policy system is over. I'm so sorry, the national environmental system in Brazil, it's over, okay? And use, consider the demographics of Brazil and the Asian population will need to identify new leaders who will be able to take forward Brazil's budding democracy. Okay? Science is absolutely strategic, as you have mentioned, but I'd like to highlight here the need to invest in the development of the new brains. Okay? And probably tomorrow we have some friends talking about this. And my last message is that Amazonia Leapfrogging means bring together biodiversity, climate change, human development, science, innovation, and sustainability. We will be promoting a hope spot in the world. The new political constitution will not be made up only of politicians. We need new decision makers, a new BP, not just beyond petroleum, but beyond politics. Okay, the global leadership will come from youth, women, diversity, intercultural, religious, social, and economics. So let's make Amazonia and Brazil great again. Thank you very much.
No, that's fine. I've had my say. So, I wouldn't know where to begin in commenting on what you just said. So I want to bring it back to Paulo, who made two statements, narrow it down a little bit, back to the climate problems. You made a comment about basically talking about land use trade-offs, which are a critical issue in thinking about this problem, simultaneously with solving the climate problem. And you referred to sustainable bioenergy, which many people would consider an oxymoron. So I'd like to hear a comment on that. But also, I'd like to hear Steve's reaction to the point that you made that you thought that the volume of carbon dioxide that could be removed out of the atmosphere chemically and mechanically, air capture, was it's not going to solve the problem. I believe that, but Steve has had a deeper experience with this problem lately on a National Academy of Science panel. And basically what we're talking about here is a bunch of choices between a bunch of not very good options. And they all trade off against each other. So Steve, what do you think about the possibility of sort of technologically taking ourselves out of the problem with air capture?
So the problem here is that we now have the technology to switch to a non-emitting economy, but only if the economy is net zero. That means we offset difficult to sources of greenhouse gases for which we have no economical or practical substitute, and we match them with sinks that we create that pull CO2 out of the atmosphere, all right? And it's pretty easy to identify how large those sources are that we're going to have to offset. A lot of them are controlled by agriculture, right? So there's N2O and methane from agriculture, and we have to feed our people. And so those are inevitable. And the problem is they're pretty large, right? So sort of 10 gigatons is the number that you want to be thinking about in CO2 equivalent terms. And so that's an enormous sink, right, that we have to create to get to net zero and reach the goals of Paris. And we have to be able to scale up to do that in like 30 years' time, right? Now, if you look at the capacity of the land to do this, because trees eat CO2 for a living and turn it into wood, so they actually take CO2 from the atmosphere and fatten their bodies with it and create a sink. And we probably have enough land in total to do this. But my fear is that because we have the simultaneous need to double food demand, that if you put a price on carbon large enough to cause land to go into those carbon sinks, we could create food price shocks that would hurt the poor worldwide. And indeed, the history of this is that food price shocks lead to violence, right? This is very dangerous. And I don't think, have the policies now to create an incentive big enough to do this without causing a land rush that would in fact then hurt all of the people that are dependent and close to the edge in their capacity to get food. And so I led a U.S. group for a couple of years that looked at the set of options for the U.S. and for the world, and we concluded that we simply didn't have enough safe capacity to do this with trees and with land use, and that we actually needed some other options. And we looked at the technology, and we think there's a high probability that it would be possible to design machines at about $100 a ton, which is 25 cents a liter on gasoline, if you want the equivalent, right? And if you did that, you could pull CO2 out of the atmosphere to meet the shortfall. It's a huge endeavor. It's by no means solving the whole problem. It's taking the residual that we don't know how to offset. We take the amount that we safely can with sort of old time methods like land use and forestry, and then this is what's left over.
Do you want to say
Yeah,
anything about that?
yeah, I think that is clear for the audience, and the main results from this is that the problem is much bigger than just leapfrogging Amazonia. You know, I think what Steve mentioned that right now, agriculture is responsible for 30% of all greenhouse gases emissions. So it's 30%. That's a lot. Even if you get rid of 100% of fossil fuel, what you're gonna do with the 30% for food production that will increase, of course, increase with the population. And that is mostly N2O and methane that are much stronger greenhouse gases than CO2. So you see that the size of the problem we're having, it's really big, that we need big solutions. So we don't have that solutions, let's recognize this, of course, developing for this carbon capture project that was mentioned, of course, this will have to happen in tropical countries because of the lifetime of the growth of the trees that only can be done in tropical countries. And in Indonesia and in Africa, with very high population density, this will be extremely difficult to be done. So probably Amazonia and Atlantic forest are possible target regions. But how can you do that? With which technology, which science, which species, how much money, how many people have to be involved on this? And as was mentioned, this have to be done in the next 20 or 30 years. That is right tomorrow. So
Paulo, if I can introduce, that's our agenda for tomorrow, okay?
okay, that's fine. That's an introduction for agenda for tomorrow. But I think that we'll have to be very creative to really find a way to do that.
Well, and I thank you so much for the presentations, the panelists. We would like to open a little bit to hear from the audience, because we had this incredible creative experiment, and we actually related to the work of Professor Nobre, who is with us here today. So we want to collect condensed short statements or probing questions, right, to make the first bundle. So Professor Nobre. Okay. Here, Andre, can you bring here? Okay, great. Okay, great.
I have a question to Elena. I guess
you will have time to think
I
about
guess
the answer.
only meteorologists, Elena, saw something there when you present the results, because it's very tiny, but maybe very important. In the last several months, because of this global outcry about the Amazon, I gave many interviews and to US media, LA Times, CNN, CBS, and all of the reporters asked me the same question. Is the Amazon deforestation going to affect California? And your results show. So now I will relate to these reporters to you. You will reply them. And if indeed you and the scientific community can advance on the understanding the remote effect. Paulo showed the Amazon is a heat source. So you reduce the heat source, you have a wave train. Sorry, this is jargon, but this in meteorology. So you have this wave train. Some of these wave trains travel all the way to California. So if we are able really to demonstrate, not the two of us, but science, that the remote impacts really affect a region like California, drying out California, that will be really very important. And then perhaps, we can ask all the Californians not to buy Amazon products from deforested areas.
That's great, wonderful. So Juliana Assunção, here? And then
Well,
then
I
Elena
have
will just
a question and comment that is more on the communication side, but I think has implications for the technical part as well. I think this work might be a terrific tool for communication, as you state, and I wonder to what extent you can use this kind of simulation in order to get a better idea about what are the impacts of those changes in terms of extreme events and things that people can really relate it to. I think that the framing of the climate issues in terms of the average degrees, I think it's a bit misleading for a general audience. And I wonder to what extent we can, take that additional step and then frame all of these results in terms of things that are more sensible along the way that, when you took the observational data like Paulo's showed, the focus was more on these kinds of events that people can relate to. So that's a question, probably not for you only, but for this whole effort of communicating about the climate risk. Thanks.
This one, let's go with these two questions, then we'll open for the next round, okay? Yes. Okay, so Elena, you want Elena and Steve to...
Thank you for your comments, and I think you're absolutely right. So as I said, there was just a first set of sort of general results, and we want to show sort of large climatic numbers like averages. But I didn't have chance to mention when we simulate weather in those models. With some models, the same models used for weather, they're just a little bit more complex. We compute state of atmosphere throughout the column at the surface, water, hydrological cycle inside the ground every 30 minutes. And we collect many, many variables. And what typically happens in analysis, which we do as we progress in our studies, we use those like 30 minutes values or 6 hourly values to compute extreme indicators, like droughts indicators, change in the dry season, extreme precipitation. So this is something that we're gonna do. And we definitely use this type of simulation to address those issues. So we just didn't get there yet, and we only had 20 minutes to report. But usually that's what Ipcc land report found. As your temperatures and your increase, as precipitation decrease, you have changes in extremes, particularly drought and heat waves. So that's been established. So the implications of those changes in globals, it means there would be more extremes, would be probably even more floods in some areas, because as temperature increases, your precipitation rates increase because just more moisture in the atmosphere. So we will definitely do it, and we can do it with these tools because we have very sort of weather-like, data when we save. And back to Dr. Nobre's comment, I think what you saw, it's probably there. That's why we look at 20-year averages, because it's not just the climate variability. And there are studies which come out of this university, like David Medvegi published a study like a few years ago, showing that changes in Amazon region land characteristics impact California in a linear-like pattern. So essentially, you create a permanent El Nino there, which might result in changes where the rain falls or where you have a drought in California. And again, we're going to look more in it, and we're going to run it longer to 2100 because the results are going to be even bigger in the baseline simulations. But I agree, we need something that's more accessible to the policymakers and the public, and we will definitely do it. And we have the means to do it. That's how you do it.
So, Stephen, you want to say a few words about this, the political role or impact of science as a communications tool?
Sure. I absolutely agree with you that the gentleman in the back, that extreme weather is probably provides the single greatest scientific opportunity now to educate the public and by extension policymakers about dangers of climate change. It used to be said until only a couple years ago that it's impossible to attribute any extreme weather event to climate change. This was said again and again and again and again all over the world. And in fact, Michael and I went to the White House, and remember that? I do. And Obama never said it again, okay? And why not? It's because the science changed.
Cause and effect.
Yeah, I mean,
We went to the White House and Obama never said it.
we went and told his science advisor. He said, and he started writing a note to the president right then.
I'm always cautious about cause and effect.
yeah. He'd said it like the day before. In any case, the point is that now no one says that. No one says that because it is now possible to assign attribution to individual extreme weather events. And it's increasingly common all over the world. You could do heat waves pretty well, extreme precipitation pretty well. Droughts increasingly,
regions.
and now increasingly hurricanes and typhoons. All right, and even a year ago, the community wasn't doing much of that at all. 2 years ago, none, and now all of a sudden, it's really pretty common. And so this has all kinds of implications, including legal implications of people who are damaged. So I agree. This is really where the front lines are on the intersection between public communication and climate science.
And Steve, just getting my prerogative, I was in line as well to ask, because you mentioned before when we were talking during the break, if anything surprised you in the results was the heat, increase of temperature in Brazil, particularly.
Yeah, I actually thought that the Shukla et al. Paper, which I've taught for many years, that Dr. Nobres was an author on, was interesting, but perhaps the result of a primitive computer model. And our result showed effects of just the same magnitude with the most sophisticated, scariest climate model that I've ever seen. And it's the combined impact of elevated temperatures and reduced rainfall that together work synergistically to dry the soil out. All right. So the elevated temperatures cause the water to evaporate from the soil faster, and the decreased rainfall cause the level. And so the impact on agricultural productivity then is much more extreme, even than each one would be separately. And so it's really worthwhile to compute again what the impact on agricultural productivity is, because it's quite probable that deforesting the Amazon to increase the food production of the region might actually send the signal in the wrong direction. Yeah.
Okay. So we had a few people who are interested, and I would like to get people who have not yet spoken. So we have Bernardo here, right? And then Fernanda, and then Robert, right? Yeah. So we'll collect a few more questions, but let's get some more people who have not yet spoken. Yes.
Thank you. Just quickly following up exactly on your last sentence and on your comment, Giuliano, I think as economists with a bit of a bias in this, there are two tools we try to use and would love to investigate the power that. One is obviously economic valuation of everything that nature provides and is associated with nature, that we actually published in PNAS last year together with Professor Nobre here, evaluation of the dieback hypothesis in the Amazon, and that got quite a bit of attention because you see 80% of the Amazon GDP going away, and that gets attention. And the other one is what you just finished talking about, agriculture, productivity, both the mean, but also the increased risk, which farmers and financiers and banks respond much more to the increase in risk than the increase in the mean productivity. So when extreme events fluctuate, it's great when we can have the full stochastic behavior and we turn that into productivity, and then we turn productivity into dollars per hectare again. So in Brazil now in particular, as the agribusiness lobby is the key one behind the push for reducing our environmental standards and etc., addressing directly them with the impact on agriculture, risk and productivity would for me be the greatest communication tool we can get from.
Let me make a comment on that. One of the things we know is that the financial sector will respond to perception and fact in terms of what future risk is and how things are changing. We don't have any idea how individual, for instance, farmers respond to those kinds of, to that kind of information. There isn't a good picture on it, and the information we have isn't actually all that encouraging in terms of the willingness of farmers to change practice in anticipation of future trends, particularly climate change.
Okay, so we have Fernanda here.
Yes.
Yeah, okay, great.
Well, my voice is bad, but I'll try. With regards to the financial aspect of it, and someone mentioned the cost to us, right? That it's visible. I think besides the fact that we're gonna have a hard time living, in cities close to the sea and everything like that. I like to mention there's a speech of Mark Carney, who was president of hi, he's working of Bank of England, and this speech is from 2015, and he was basically mentioning that the weather-related loss events for insurance companies tripled since the 80s. So the losses were around 10 billion, and now they were reaching 50 billion in 2015. I think it's even bigger now. And going forward to predict scenarios, they are having a hard time because the disasters are going to be bigger. So the losses are even bigger. This will affect asset prices since these insurance companies will have to sell assets, right? So this will affect the market. So a way I try to look at it is when we build portfolios there, we say what we can do today when we invest the portfolio, our money today is a portfolio of a world that is finishing. We won't have it anymore. So we invest a little bit in impact. We're trying to change it to ESG. And we say this is a hedge for the future. This is a portfolio that will, represent the future. Still hard because most of the people, they want to know what the return was. And few people want to know, is this destroying the world or not? What is it doing to the world? So I think this type of information with the insurance companies, or there are many other texts on that, this can show the cost for everybody. And can talk more about that
We'll
later.
continue tomorrow. This is very powerful. Thank you. Robert? Yeah? Can, okay.
Just thanks so much to the panelists, I mean, here and before, for really powerful and visually stunning presentations as well. Just two really quick questions, because I want to give time for the answers. The first is this idea of communication. I'd just be curious to hear from the panelists, what are the vectors, of the mediums, of the platforms that, from your perspective, are going to be the most compelling to communicate some of this very complex and often highly uncertain sets of results? I know Climate Central has got some wonderful dashboards and some projections. I'd be curious to hear what you're thinking about in terms of showing some of these longer term trends, and how are you going to get them out there and push them out there? I'd just be curious what powerful tools exist to do that. And the second question is just on the modeling. A lot of discussion now about planting an abundance of trees and investing in how would that offset your predictions if there were to be a major surge, for example, in planting new growth? What does the model say about human intervention when it comes to actually new vegetation and new forests in terms of reducing those outcomes?
Great. Good.
So on the first question, Climate Central is an organization that was founded and based here, and in fact is based here. And in fact, several of the people in the audience attended a board meeting of the organization today, and there's at least one vice president in the room. So the most effective program we've developed, in my view, is one that partners with TV meteorologists everywhere in the country. Now there are 800 of them, and so that covers almost the entire. Yeah, it covers the entire United States. And they're building right now an automaton, a computer program that monitors the weather every day and then analyzes whether or not the weather is anomalous, and even does an analysis to figure out the magnitude, the attribution of the fossil signal, especially if the weather is extreme. And increasingly, we'll focus on economic impacts associated with that weather, for instance, a decrease in agricultural productivity, and then assemble a custom piece for the local viewership and send it out every day, because there needs to be a drumbeat so people understand that because climate change is already running among us, that they are in fact being damaged. That's the way to help increase the political pressure to get something done if constituents who vote are worried about it. Interestingly, and Karen maybe can say something about this, there has been a proposal to develop exactly that same network in Brazil. We actually discussed it today. So if anybody in the audience has a lot of money, all right, we'd be interested. The, what was the other question? Sorry, I got sidetracked. Oh, yeah, go ahead.
Okay. The question was about afforestation and reforestation. The scenarios which we showed, that base SSP1 scenario, which still produces about 2.5, 5, like 3-degree warming in Amazon, it assumes major afforestation, reforestation around the world, and including on the periphery of the Amazon. So that's your base case scenario you get. As you go to warmer worlds in which you don't have that, much higher warmings, some places might not be able to sustain the forest as they have. So we could simulate different alternatives and we could develop those scenarios, but I don't think, it's going to change the story unless you cut fossil fuel production. I think like land-based mitigation is just a band-aid, and I'm sorry, I don't think you could save world with popcorn. So I think what people need to do, they need to think about technologies to remove it, alternative ways. But this whole story that land-based mitigation major player in removing, I think it's just hopeful, but it's major risk for the food systems, and it's a major risk for the climate as we know it.
And then we have want to hear from Paulo, some keywords.
Yeah, I just want to complement the important comments on the communication issue, The difficult for me is to communicate and speak to somebody who do not want to hear. Second point, when Trump says, I don't believe in climate change, Trump and many others, Bolsonaro also, what they are saying is just they are responding to economic interests. Because science is not religion, you cannot believe, you can believe or not on your wife, on God, on your priest, or somebody else, but science is science. It's not an issue of belief or not. So the problem of communicating is central to what the economic interests are behind that particular economic sector, person, or something like that. In the case of Bolsonaro, for instance, of course, large landowners in Amazonia who have a predatory behavior against Amazonia are behind him. And he is just paying back, the investment that these people have done on his campaign. And the same with many other politicians on the world.
So, segura só pouquinho. We just want to hear, because Anatoni wanted to ask a question. So yeah. So we want to collect 3 more questions. So we have Anatoni. We want to pluralize the more diverse voices, right? So we have Anna and then Anne, right?
No.
And then I want to hear from Tasso. Tasso, you worked very closely in conversation with Elena. I want to hear how you think this modeling. Thank you, Michael. So we want to hear how you think this modeling could be developed further with evidence materials from map biomas, for example. Where do you see the potential of transforming this modeling in a technology of sorts, right, that could be used for thinking in terms of policy action, right? So.
Mine will be a very short question. Thanks very much for both panels, this one and the other one. Is how are you guys communicating with the military? How much interest is there from the military on the data? Because Isabella mentioned, is huge security issues there involved, and I wonder how the communication between the scientists and the military is happening. And the second question, which is more like a political one, can we really solve and save the Amazon without solving Brazil's judiciary system? Because a lot of what was talked about, so much illegality, and we know that 5 or 6% of the Amazon fines are paid. So we talk about how to protect and how to make trade, and finance. But in the end, we have a huge legal problem there that brings a lot of uncertainty for all the other solutions. Thank you.
Yes, please, Anne McClinton. Yeah?
Yes, actually, my question, I think, was just asked, but it was really about the military. We know that militarization is probably one of the largest, if not the largest, causes of environmental devastation. And I'm just wondering, as a source of pressure, thinking of Steve and Michael having a word in Obama's ear, whether you think the U.S. military are now it's one of the groups that really have been for decades aware of climate change but reluctant to be very public about it. One of the generals said, however, that climate change might extend the conditions of the war on terror forever. So just wondering if there's maybe some shift in their policy given the kind of vested interests that we've been discussing.
Very quickly, answering Anatoni from the Brazilian side, climate negationism is something rather new in Brazil, at least in the scale we're having right now. It started actually with the new government, and it is very curious that the military house, the Casa Militar in Brazil, asked many scientists when he started to hear the Minister of Foreign Affairs saying, okay, climate change does not exist, he asked several scientists that I know have made testimony to them, is this true? Is this real? Is this just, what exactly this means? So they went to science to get the right answer. They were not. They did not went to the believers or not in such a strategy or not. So the Brazilian military at least have, I think, a sincere need for reliable information on this critical issue. I don't know about the United States.
So we hear from Isabella, and then
Yes.
final remarks from Steve and Elena, and want to hear from Tasso.
I'd like to add two comments. The first one is that you have difficulty when you have to address short-term needs versus long-term vision. Okay, and if we go to the governor state of Pará here, and let's talk about defense and security. Let's talk about organized crime, how we can measure better the penitentiaries, how we can solve the problems, and also the pressure for organized crime and deforestation, and also how it impact mining industry, et cetera, and state GDP. And behind the scenes, we have fossil fuels industry, et cetera. And to give an example, Brazil has pre-salt investments, and now we have the new pre-salt dynamics, we can say this. And I'm convinced that no political player in Brazil will be against this. Nobody. Are you able to, okay, I don't need money from the royalties from pre-salt exploitation? As a governor, you will take decision at this moment, consider the economic crisis in Brazil. This is short-term decision. And it means that the next 35 and 40 years in Brazil, you have the rise of fossil fuels used in our energy mix. It's this. This is the real world, my darling. I'm so sorry, but this is the real world. Okay? And you want to discuss climate change? Okay, let's discuss nature-based solution and how we can capture carbon based on restoration. And now I just received a new, again, against forest code in Brazil. The National Congress take decision against the forest code implementation. And the judiciary, the Supreme Court, took decision that we need to implement forest code. This means politics in the short-term perspective, and also a robust new government, because it's supported for our population. I'm against, but otherwise, okay? And they guys, they are taking a decision today that we will influence our future in the next 10, 20, or 30 years. That's why I mentioned that we need a new politics. We don't have a politics for Amazonia and for climate change. I'm so sorry. We had diplomacy in the past. Even diplomacy. What's happened with Itamaraty in Brazil? One of the best diplomacy in the world is completely destroyed. Okay? It's out of the game. Okay, and we need to understand how scientists and other players can bring this inside. And come on, let's discuss. I'll give an example about militaries. Okay, I don't talk about militaries in the United States because I should be careful. But I'm going to Berlin next week, and I'm showing a debate there about democracy and authoritarianism. Okay, and then Antonio, Anna, you promoted a seminar last year in Brazil about defense and climate change. And our Minister of Defense in Brazil was invited to be there. And I remember that you mentioned this to me. It's unforgettable, okay? A bad memory. And the Germans were there exactly discussing climate change, security, defense, the new concept, tipping points, science, vulnerabilities, droughts, how we can impact economy development, and also social conditions. Our minister in Brazil said that all the militaries, how can I say, works and installation, buildings, everything in Brazil have environmental licensing. This was his position. Environmental licensing is an agenda from the last century. It is starting in 70s here in United States. And you host this in 69, and you host this in 75 in Brazil. Okay? So we are discussing about politics today. That's why I'm trying to say that how important the science is to put pressure, not only to put pressure, but to play politically. Learn how to play politically. It's not only to say, this will probably happen. No. That, as we mentioned, if we're not able to manage better climate change and also fossil fuels, the huge responsibilities from developed countries, okay, forget it that you can have short-term or medium-term perspectives to solve the problem.
Okay. So can we hear now from Steve and Elena some final remarks and maybe a quick word from Tasso about what's next for the modeling?
So I just want to comment on the military interest in the United States. I've done a fair amount of interacting on that with the military in the U.S., and there's no question about it. They take this extraordinarily seriously. They believe the science. They have to be evidence-based managers of risk, or many of them would be dead, okay? And so there's no doubt about where the military stands. So the question is why, if the military's not behind it, why is the political situation the way it is in the United States? And we've heard a couple of times that it's because of financial interests. And I actually think that's a good historical explanation, but not the current explanation. The fact of the matter is that technology has changed. The cheapest form of electricity to install, and 2/3 of the Earth's surface is already wind and solar. That's everywhere in Brazil. And so increasingly, virtually the entire apparatus of capitalism is behind serious action to get to a net zero economy in the United States. What we have here is a political problem, and it's the holdover of a political, and in my view, cynical calculation to make this a partisan issue, all right? This is going to be difficult for the U.S. to work through, and the only thing I can say is that the political situation here makes me feel more than ever like the brother of the Brazilians, because they're facing something that's not altogether dissimilar. Right.
I just want to make a comment which is slightly different in tone, because I don't communicate to militaries in US or Brazil, fortunately.
How about
right?
Russia?
No. Thanks God. Unless they listen my phone, you know. Maybe
What a
they're listening to the
triangulation, huh?
phone. They're
What a
listening to everybody, as
triangulation.
we know, right? So, but one of the most empowering experiences I had was during the plenary when, we presented the land report to approval to 150 governments, right? And it lasted like for a few days through the nights. And I was really surprised. I didn't anticipate it. That most of the governments in that room in WMO wanted to recognize how climate change affect their region and their country. And there were countries from South America in that room who wanted to recognize climate change impacts on their country. They wanted to put it in SPM and say this region's been like having more droughts, more extremes, like more floods. And there were countries from Middle East, all producing countries, which were interested in that as well. I think the state of the play right now is that most of the countries, with exception of the few, us, right, who actually looking for more information about science, who are interested in the pathways how to get there, including the oil-producing countries. And I think communicating the results at the regional level and showing alternative pathways. If something happens or doesn't happen, what is the benefit or the cost of avoiding that? That's what we as a scientists trying to do here. And I think hopefully in the future, we would have no doubters. And hopefully, we could provide a better science and provide more information to make those decisions where Brazilians as a country could make their decisions by themselves.
Okay, so Tasso, you want to say a few words? Next steps or something? And then we'll wrap up. 30 seconds. Yes, go, get it. No.
No, I'll just say Yeah, first was fascinating that we have this opportunity to, after that conversation, I don't know, that was May, right? Um, um, yeah. So first, thank you, Steve and Elena, for doing that. I know that Elena was working on something else, and then we basically convinced her to drop everything she was doing to actually do this exercise. And actually, it opens a window of many things that we could think about this type of modeling, which is very, very powerful. So the three things that we are seeing right now, the first one is for this exercise, to when we decide to say like 50% cut on the forest, we couldn't kind of assign exactly where this will happen. So it's a kind of more randomic, we'd say like just 50% somewhere. But actually, we know we have many different modelings that we can do with map biomas. IPAN has other ones, and etc. We can actually tell if you say if there is 50% that will go in Brazil, where it will happen. And so we can precisely modeling that on a very precise way, which is very important because then we can understand the value, for example, of the protected areas, the indigenous reserves, and so on the model. So one of the exercises to actually be more like real with this thing. The second one is this whole thing about the feedbacks, because that was the feedbacks on agriculture, feedbacks on the forest itself, because maybe if we cut down 50%, is actually the same as closer to 100 because you lose the forest somehow, etc. So I think this is what the second thing, which is like the impact of the whole thing in the forest itself would be very important. Another is to understand better, and I think this is the point that Juliano has put out, and which is very good. That we have, this is like just like we just saw, as I understand, we just saw like the spill of the modeling, right? It was just like the first drop that went out of the modeling, and there is like tons of things that will come from this modeling that we have to translate in something more tangible in terms of weather. I think will be like absolutely fantastic. And I want to we want to build this conversation on something that can bring together scientists in Brazil, in here in Princeton, and so on, to kind of see what we can get from there, and try to answer questions that will be closer to the practical decisions that has to be done by policymakers, by business people, by investors, and so on. So I think this was an amazing journey to do this so fast. And I really want to thank again for the generosity of both of you. We know that for scientists, like the whole thing is like you have to do the work and then you have to publish and pass to peer review, blah, blah, blah. That's how the thing works, especially here, right? And so we asked them really to generously say like, just do it and let's show that. And so it's before you're having all this normal process, it's really demands for you to be very, very, very generous.
That speaks
with us
so
and
highly. I want to echo Tasso and Beto's words. And thank you, guys. Thank you. Thank you. Yeah. Okay. So, and our João Salles here already just published a piece on the modeling in Piauí, and we like to call it the Brazilian New Yorker that he has helped to fund it. So it's already out there. Jornal Nacional tonight, the Brazilian main broadcasting company is having a report on this. 50 to 60 million people will watch it tonight. So we cannot thank you all enough, Elena and Steve, but Isabella and Paul as well, for your wonderful comments, provocative comments, a great kind of template of things we will do tomorrow. And again, Beto, Tasso, and Esteban, Mike, all of you. So there's a wonderful reception out downstairs. You're all invited for the reception, right? And for the people who are invited guests for the closed session tomorrow, see you all soon, and we'll continue the conversation tomorrow then. Okay, thank you so much, everyone.